Feross is the founder and CEO of Socket, a developer-first security platform aimed at protecting companies from software supply chain attacks. He's a big contributor to open source. He created open source projects like WebTorrent, StandardJS, and others, and worked as a visiting lecturer at Stanford University, where he created and taught the course CS253 Web Security. In this conversation, we talk about open source development. We talk about the companies that he developed over the years, Socket, security in general, and how LLMs will change the security landscape. It was a really interesting conversation. I hope you guys enjoy. All right. Thank you so much for coming. I'm really, really excited to talk to you. You're a legend in the open source community. You've built so much open source code and been building tooling. I remember YouTube Instant. I use a Chrome extension on top of your YouTube Instant website, and you've been building for a long time. So it's really nice to see you now with Socket and building a company that's very, very important for software and software development. Before we start, I wanted to already dive into open source development. You spend a lot of time into it. You didn't spend much money, so you could spend a lot of time in open source development. What are some of the lessons that you've learned working in open source development over the years?
Yeah. Well, thanks for having me on the show, first of all. It's great that you remember YouTube Instant. That was one of my first projects I ever worked on that kind of got some attention on the internet and showed me like the power of the internet and the reach that you can have. So it's cool that you remember that. Yeah, I mean, when I was working on open source, I think one of the things, I mean, there's a whole bunch of lessons, but like I can think of just a few that come to my mind. So one is like, just putting your work out there is really powerful. I think a lot of people have reservations about putting code online. They are worried it's not good enough. They're worried that people will judge them. And I think one of the things I learned was, I mean, my initial code was terrible, right? It wasn't good at all, but that's okay. Cause I kept publishing packages and trying to solve my own problems. And after not too long, maybe, a year or so, I was, people started using my code. So I think, I just see a lot of people, they're interested in open source. They're interested in the idea of sharing their code, but they sometimes can feel a little bit hesitant to put things out there. And, the truth is that I think people either they like what you're doing, they use it, or they just ignore it. And it's often not the case that somebody will, that there's really any kind of downside other than people just ignoring it or not noticing it. So it's really only upside to putting your work out there. So I think that's one kind of mindset thing. I think once I actually got started doing open source, a few other lessons come to mind. So one is, I think it's really important to, create a welcoming community vibe in order to get people interested. So giving talks, writing about your work, encouraging people to contribute with issues for, creating some bugs, leaving them open that are easy for people to come on and do as their first issue can really encourage people to come on. And then you can, over time, kind of like cultivate those people and then add them as contributors over time. So you end up with a healthier project. I think that was one thing that worked really well for some of the projects I worked on, like WebTorrent. And then like one thing I think is a mistake I made that I learned a lot from, that I'd love to, just give advice to people who are doing open source, is for some reason, I never really met with the people who are working on the project. We really, there were a lot of people collaborating together, but we never really had like a weekly call or kind of in-person meetups or things like that. Even something like a weekly call to get to know who was behind, the GitHub username. So that was something that we could have done that would have been really easy to do, but for some reason we just didn't do that for like years. And we really mostly collaborated through issues and pull requests. And I think there was a little bit of missed opportunity because the people behind the project are actually really cool. And now one of them is even working at Socket with me on my current company. So after I actually finally got to meet the people behind the usernames, it turned out that a lot of them are really cool and great people. So that's just one thing I can't quite really put my finger on why we didn't do it. It just didn't occur to me until later, and I realized, oh, a lot of other projects do these weekly calls where they get to just talk to the other people, communicate in a non chat text based format, and so yeah, easy thing to do. We didn't do it, but I think people should.
That reminds me a little bit of crypto projects because there's a lot of open source development and some projects have weekly calls, and I didn't realize how important that was. So, I mean, you have a lot of experience in open source development, and you've probably seen over the years how it evolved. Even with Facebook releasing React, Facebook was a big part of open source. But in the past decade, there were a lot of businesses building open source projects and building, their business around it. So, for example, you have Supabase, you have even in the AI space, you have Mistral, based in France, you have GitLab, and so on. How did you see the open source ecosystem evolving, at least in the past decade?
Yeah, I mean, it's a great question. When I worked on open source, I think it was the beginning of the Node.js and NPM kind of era. So this was like 2013, 2014 is when I really got involved. Node really started in 2010, 2011 was when really the momentum started picking up. And at the time, I think that what the evolution I saw was before Node, open source projects felt a little bit like a, what's the word for it? Like a secret society or something where it feels like, how do you even get involved, right? Like obviously there were mailing lists and no one was trying to make this stuff hard to get involved in, but it just felt to me, when it could have been maybe my age. I was in college at the time when I started wanting to get involved in open source. And it didn't feel like until Node, until JavaScript, it didn't feel very accessible to me. Even some of the way these package managers work, they're designed to, there's a vetting process that kind of, you almost have to ask for permission to use a package name. And there's a lot of like checks and things like that, which are good for security, good for curation, but can lead it to be harder for people to kind of get involved. And so the kind of shift I experienced in my formative years was this sort of open, uh, this reaction to that old way of doing things, and with GitHub making it really easy and standard for how to contribute to project. Every project went from having its own mailing list and its own weird processes to everything being standard, issues and pull requests on GitHub becoming the norm, and then NPM encouraging anyone to publish. The publish command is like one command, you run it, and that's it. You're a publisher of open source. There's no huge ceremony. It's not a complicated process. And so I think that era was really all about like openness, accessibility, inclusivity, right? All this stuff to get more people involved. And now what I see a little bit more of is kind of a counter reaction to that. And people wanting to pick fewer dependencies, and kind of a reaction to the overproduction of too much open source, it's too overwhelming. There's too many people that you have to trust. And so I see kind of a desire for fewer but higher quality kind of dependencies and a shift toward that. I think part of that is driven by security, interest in software supply chain, which I know we're going to talk about later. But you're asking about the commercial side. I mean, I have less experience running an actual kind of a company that publishes open source software that has like a kind of a free and a commercial version. Socket is more of a SaaS tool. People do open source for all kinds of reasons. I was more on the individual side. Like I just wanted to see this code exist when I was doing open source. I just put it out there. Didn't really have a plan for business. Everything was MIT licensed. There was no paid plan or anything like that for it. But then you obviously do see people doing open source as a strategic thing, like for their startup. Offering an open source version can make it feel more comfortable for companies to adopt a tool if they know that the open source is always going to be there for them if they didn't want to stop paying or if the company goes out of business. And then you also have obviously companies like big multinationals that do open source like think like the Chromium project, like the Linux kernel, that type of thing, where they have, full-time employees being paid to do open source in a way that doesn't necessarily directly translate into you know, revenue, but is just like part of a bigger strategic thing for the company. There's all kinds of reasons to do open source. Um, yeah, I don't know if that answers your question. It was kind of all over the place, but I think, yeah, yeah, that's some random thoughts, I guess.
That's very interesting. Yeah. So let's dive in a little bit more into the individual process. Um, I imagine that you encounter some problems and some intricacies of developing uh, open source code. If you were looking, in the next 5 to 10 years, which areas do you think the development of open source, what kind of tooling and what kind of things would need to improve over time? Like what areas do you think open source could get better
Mhm.
in the next 5 to 10 years?
Yeah, I mean, I think the biggest thing that's on the top of my mind is just the way that we manage our dependencies in open source, because there's been a few shifts that have happened, and I think it's caused um, pain in the open source community. So I alluded to one earlier, the idea that we now have way more open source out there. That was, I think, mainly driven by NPM, but now you see it in a lot of other ecosystems as well. There's just been a massive explosion in the amount of open source. You see the Rust ecosystem with Cargo, their package manager is modeled a lot after the way NPM works. So there's just a lot of people publishing. There's a lot of code. You depend on a lot of people, a lot of maintainers. So in the old, in the pre 2010 era, a lot of the time you could list out all the open source you use in your application. It was these very big dependencies, things like jQuery, PHP, Apache Web Server, WordPress, Linux, right? Like it was things like that. And now, if you ask someone to name all the open source they use on their website to build their website, they can't. It's like thousands of, right? I mean, just to get Hello World on the screen, it's like 1,000 dependencies. I'm not even kidding with React. That's how complicated these frameworks have gotten, and just how many, how tiny the components have, you know, been broken up into, right? So, but yeah, I think that's like one thing. It's hard for people to manage that, to know that they can trust that, to know that to know how to update that and keep it up to date with, you have that many dependencies changing. Um, how often should you update? How do you fix vulnerabilities that are present in the dependencies that may be deeply nested down the dependency tree? So not even something that you can really necessarily control yourself as a, as a person who installed the dependency. So there's just like a lot of issues that come up around dependency management, I think. And I think I mentioned before, there's been a bit of a backlash and people trying to use packages with fewer dependencies. I even see a lot of people now marketing that as part of the reason why you would, a feature of their open source project. Some of the times they'll say zero dependencies, no dependencies,
Oh,
marketed as a feature sometimes. Yeah, so I think that's kind of one thing. I see. The other area is around business model. There's been interest all throughout my time doing open source and how to make open source sustainable. And I continue to see experiments by different companies, by different individuals, by different groups, trying to make it easier for maintainers to make money in one way or another from their projects. And you'll see companies doing licenses that are not technically considered open source by like a large part of the community, but which help the company to exist and to sustain the development of the project. And then, we continue to see some more of these types of projects based on donations, where you donate and they try to distribute the funds to the different open source projects you depend on. So I just keep seeing more of that type of stuff. I don't think it's a solved problem, and I think people continue to, you know, realize there's a problem here, and we continue to see reasons why this is a problem. So it's really not been addressed, right? I mean, you probably saw the news about XZutils, the package that was compromised,
yeah.
and
I wanted to talk about it. So
yeah,
yeah.
yeah, we can talk about it. Yeah. But anyway, that's a great example, I think, of this sort of, lone maintainer working tirelessly for over a decade to maintain something that is used by everybody, but that nobody realizes they use. And it's like that famous XKCD comic where you have all the tower of things built on top of this like one random maintainer living in the middle of Nebraska or something like that. Uh, yeah, so I think that's a big problem, and that contributes to the whole trust problem of like you know like I don't think anyone's going to stop using open source. This isn't like necessarily, I would say, existential problem, but it it does slow the adoption of open source, and it does create lots of friction. So I think it's an important problem to solve.
I've heard you mention that, for example, Google, they consider whenever you install code, they consider their own code. So they try to maintain and things like that. And I wonder if, other companies that are using open source can learn from that in some way or another. But yeah.
Mhm.
Cool. So let's shift a little bit of focus into, some of the projects that you've built. One of the most interesting ones that I came across is PureCDN, and I think it eventually became WebTorrent. Um, can you talk a little bit about the idea behind it and talk about if it was hard, what was hard about it?
Mhm. Yeah. So look, I've always enjoyed building projects that surprise people in one way or another. In college, I used to enter a lot of hackathons and just like to build things that had, really cool demos that had like a lot of pizzazz and would surprise people. Like, wow, I didn't realize you could build that, or I didn't realize that was possible, that type of thing. And so one of the things I was doing in, in like couple months after I graduated college was I was looking around at different web APIs and trying to learn like what is coming in the web, like what new features are landing. Cause this was back when, the web wasn't fully like, it wasn't fully like an operating system yet, like it is now. Now you can do basically everything in the web browser, right? Very, very powerful APIs. We were kind of still at the earlier days of that. So you still couldn't do video calls like we're doing today right now using Riverside. Uh, you couldn't do, you had to use Flash for a lot of things. So it was very exciting to see all the features the web browser was getting. And I remember I would look through change logs for the different browser vendors and use that to get ideas for new apps to build, new products to build. Because it felt like every time a new web API landed, there would be like a company created in response to that. Like if you think about WebGL, right? WebGL allowed Figma to exist, right? Massive.
Yeah.
Right? So every time one of these would land, it was like, okay, another company is going to come from this. And so I saw WebRTC, and I remember thinking that it was really cool, and you know, thinking what can you build with this? And what WebRTC lets you do, obviously, is lets you control the webcam and the microphone from a web page, but also it lets you open up connections from one browser tab to another browser tab. So like I can connect my browser to your browser directly with a socket, and we can send data across that socket. So, you know, that's cool, right? You can build stuff with that. That's better. It's more real time. That has lower latency, and that's why it's important for video and voice calls. But you can also build peer-to-peer systems, so decentralized networks. And I remember I used to think WebTorrent or BitTorrent was really cool at the time, and so kind of the idea just came like, hey, why doesn't somebody build like a system for distributing files over WebRTC. And then, the kind of one idea for what would this be useful for as a business was CDNs. Like companies pay a lot of money for CDNs to host their files. And what if you could just have all the visitors on a website that's really, especially if it's a really popular website and there's a lot of people online, could you have them just host the content of the website and just make it like kind of a decentralized website? And that was the idea for PureCDN. Was it was a script tag. You drop it onto your web page, and then kind of magically all the static content on the site, so images, videos, audio files, large downloads would be magically, all those files would magically be distributed over a peer-to-peer network without any other changes required by the website owner.
Interesting.
What that company was, and and it was I think it was ahead of its time, and I actually maybe in hindsight it wasn't even that good of an idea, but it was a cool idea.
Why
And
why wasn't a good idea? Like it just seems that it makes sense that this is gonna be built at some point. Why do you think that wasn't a good idea?
well, I mean, what we learned was um, website. I mean, so first of all, I learned a lot of lessons while working on this company, but I'll just mention a couple. One was um, we didn't talk enough to our customers. So
Mhm.
common mistake that technical founders make is they just build things and they think, oh, if I build a cool technical product, the customers will show up later. Obviously, that isn't true, but it's easy for someone who's technical to think if I just make it really good, if I just build this thing really good and it has all the features that it needs to have, obviously users will recognize how awesome it is and they will
Yeah.
show up. Like that is how it works. So we spent a lot of time like building, like solving technical problems to make this thing work. And there were a lot of interesting technical challenges and it was super fun, but we didn't talk to customers early enough. And then so when we started talking to them toward the end of the company was only around for about 8 months from beginning to end. Um, Toward the end, we learned from customers, from potential customers that uh, when it comes to their CDN, they actually care so much about reliability. Like reliability is and consistent performance is like super important. Like they and they would pay for better performance and better reliability. Like if you give them a choice of a CDN that's like twice as expensive, but it's like 30% faster, right? And and it's more reliable. Like a lot of companies would pay that for the improved reliability and and the improved speed. Because if you're an e-commerce website or you're, like most websites benefit a lot from having, from fast performance, increased conversions and CDN isn't for a lot of companies isn't like their top cost. So our value proposition was we'll reduce your cost by offloading all this work from your CDN servers to your visitors. And like that just wasn't a problem that like that many people had. Like only a few really big websites that hosted lots of content, like image sharing sites or video sites, really cared. And even for them, it was like a top 3 expense. Like look at Netflix. I think CDN is even for them, right? It's like I think at number 2, maybe number 3 expense. Actually, I think it's number 3 behind licensing, like content licensing fees, and employee like salaries. So even for a company that's basically all they do is just host video, like only number 3. And then for all the other businesses that are out there, it's like number 4, 5, 6, 7, 8. It's like not even a top 3 priority. So the risk of unreliability introduced by an unproven technology and incomplete browser support at the time and potential performance effect, like we weren't able to improve the performance. We actually reduced the performance, but we saved on cost. The reason why we reduced wasn't because WebRTC was um, you know like a problem. It was actually because of uh, it was just too early. Like there was necessary technology in the browser that didn't exist yet. Like the service worker API was needed really to intercept these connections, and that didn't even exist yet. So we were forced to use all kinds of hacks to intercept content loads that ended up like actually contributing more to the latency. So it was just kind of too early in terms of the browser maturity and yeah, not solving like a super important problem for like most people. So yeah, I don't know. I agree with you though. It seems like it's one of these ideas that just seems like it ought to be the way the internet works because the internet is a distributed system. It is a peer-to-peer system, but yet we've pretty much only use it in a centralized way these days through the web and through HTTP, where you basically have a client and a server, and it's a very subservient relationship where the client, it can't really do anything without a server. And so there's a lot of power imbalance. And the internet is itself not like that. The internet is a very peer-to-peer system. Everyone has an IP address. Everyone is equal. But in practice, like we always build services in a very centralized way, even though the foundations don't necessarily, um, yeah, make it necessitate that we do it that way. It's just like an accident of history.
Yeah, no, that makes sense. I think there are lots of lessons there, especially for the business side. And talking to customers, that seems like a very very important lesson. So let's shift towards now Socket, where you've learned those lessons. you went through the process of building, your CDN, and now you're focusing on Socket. Can you talk a little bit more about how the idea came about and talk a little bit more about Socket itself?
Yeah, of course. So, yeah, so the idea for Socket it came about for a couple of reasons. Really, I noticed back when I was a maintainer just how big the supply chain was, the software supply chain. Meaning, you know, once I started seeing people using my open source software, it was pretty shocking to see who was using it and where it was being, like, big companies using something written by someone who was in their early 20s, right? It's like, I don't know what I'm doing. Like, my previous open source had 0 users and now this one is getting used. Like, do they realize, like, I don't know what I'm doing? It's just it, but no one really knows what they're doing.
I mean,
Everyone,
you're very, very, very good. So I think you're you're a little bit humble there, but yeah.
I mean, I appreciate you saying that, but I think really in the beginning, in the early days, if you look at some of the earliest packages I wrote, they were pretty bad. Like, they were pretty useless and not that good. Didn't have much of a reason to exist sometimes. But I think that's how you learn. That's okay, right? And I think like I just realized, wow, the reach here is pretty broad. Like, and then I started seeing other maintainers who didn't necessarily have the best security practices, to be quite honest. And I felt like my responsibility over this open source was like a very serious responsibility. Like, if I, put out a bad version, it was going to affect users, it was going to affect companies, and I took the security of the packages really seriously. But I saw a lot of people who didn't take security so seriously, to the point where I even saw like one person had a 6-letter password for their NPM account. And I remember thinking, this person was a massive maintainer, like very popular packages, one of the most downloaded people, hundreds of millions of downloads, right? And um, I saw him type his password one time, and I said, "Your password's like super short. Like, how many letters is it?" And he said 6. And I said, like 6-letter passwords can be cracked like instantly. Like, they're not secure at all. Like, you should make your password longer. And he was it's not a big deal. It's fine. Like, I don't like the idea of worrying about these things and being paranoid. Gonna be fine. And I'm thinking, this is not good. And there started to be all kinds of other incidents happening in like around 2017, 2018, with packages that were getting either deleted, like left pad incident. If you remember that, it was a very famous, it was the day that everyone's builds on the internet broke because somebody deleted a packet, and turns out it was used by everybody. And this guy just deleted the package, and everyone's builds broke, like literally everyone on the internet, like for like a day, basically, until the package could be re-uploaded by npm. And you started to see these kinds of things happening, like the fragility of the system, right? The interdependence of it. And so I just kept thinking, like, there's definitely some risks here. And then I started to see supply chain attacks, people intentionally adding malicious code into packages to attack specific companies, or to just steal cryptocurrency, steal CPU time, that type of thing. And every time these things happened, I would look at the you know incident, and it was always really clear that if someone had just looked at the code, you would see the attack, because it's like they just added it into one of the files, and you could see, oh yeah, we're gonna steal all the environment variables, or we're gonna download this cryptocurrency miner and we're gonna run it. You could just see the code, and that added. But then it made me realize no one is looking at the code. Like, people are just using open source without reading the code. And I didn't know that people did that, because I always, as much as possible, try to understand the code I'm using. And I think I just hadn't realized until that time that just how many people just install and hope for the best. And so it was kind of a combination of these things that got me interested in the area. And yeah, and then I'm happy to tell kind of the exact moment that I decided to do it. But but that's kind of all the influences that were leading toward it.
So, I mean, you talked a little bit about security vulnerabilities, but what kind of real threats does Socket prevent besides security vulnerabilities?
Yeah, so security vulnerabilities are just a starting point for
Hmm.
security. The reason is security vulnerabilities are really accidental bugs that are introduced by, good people. So if
Hmm.
I'm a maintainer and I make a mistake and I have a bug that causes a security problem, that's when that's discovered, we call it a vulnerability. We report it to this central authority that tracks these vulnerabilities, and then a lot of our tooling will warn us if we're using code that's vulnerable and advise us to upgrade. And I think a lot of people are familiar with seeing these types of vulnerability warnings and different tools they've used. Now, a lot of the time, that stuff's pretty annoying as a developer to see all those alerts, of vulnerabilities. You see like 100 vulnerabilities, and it's like it just feels overwhelming. Like, what am I supposed to do about that? Like, it's too many vulnerabilities. It doesn't feel like it's very actionable, or there's really any next step I can do as a developer. And so I like to really like emphasize the distinction between a vulnerability and a supply chain attack. So a supply chain attack is different because it's not just an accident, an accidental bug. It's actually an intentional attack where a malicious actor has either, compromised someone's account, or been given legitimate access to a package and then decided to basically backdoor it or insert malicious code. And that's because it's an intentional attack. It's different for a few reasons. So one is it will affect you right away if you run the code. Like, oftentimes, right, this code it's just going to immediately run when you install the package. And so, in order to defend yourself from a malicious package or one of these supply chain attacks, you have to read code or vet the code or catch the issue before you install it, not after. Um, with vulnerabilities, it's actually possible to fix it later. Like a lot of most companies have hundreds of vulnerabilities, thousands of vulnerabilities that are in their software, and they're either just like low severity, not a big deal, or not very easy to exploit, or they're just in a backlog and we haven't got around to fixing them yet. They're just sort of on a to-do list, and that's not great from a security perspective, but it's also it's not like terrible in the sense that someone has to come along and find the vulnerability, and then there's a lot of steps between the vulnerability just being there and someone exploiting it. And so they're just different in that way. Like, I think an intentional attack is a lot more severe. It's always going to be bad. It's always going to immediately cause a problem and cause like a breach or a data loss or a ransom incident or user data to get stolen. It's always going to lead to some immediate problem. And so we need a different approach to catch it, and we need a different way to like stop it before it gets in. So we can't wait around for a security researcher to find this problem and then report it, and then eventually the tooling to warn us about it. We need to actually catch it immediately. Like, say that like a very popular package is compromised tomorrow. Like, say React was compromised, right? The community will catch that eventually, but like, how many people will have installed it before it's caught, and how much damage will happen? That's the question, right? How many people will be affected? And that's basically what Socket is able to do. Is we scan the source code of the dependency, that actually looking at the code to find these types of attacks, which is different than a lot of the tooling that came before that was really focused on the vulnerabilities. Um, because that tooling really just uses this database of vulnerabilities that's shared by a lot of different vendors in the space. And what we're doing is Socket is doing is very different. We're ourselves downloading every one of these open source packages and doing scans and looking for problems and using LLMs and all kinds of new techniques to find threats. And then we catch them before there's any public report yet. And that way we can protect our customers and our users from attacks.
And can you talk a little bit more about why that's important for companies? So let's say I'm running Google and I'm running code there. Why is it important for Google to find these problems in the code? Like, what kind of value does that bring to companies?
Yeah, yeah. Well, I mean, I'll give you an example of an attack that happened recently. We saw an attack in December against a company called Ledger, and
Yep.
they had a software supply chain attack where, um, you know, they published a JavaScript SDK, and they had an employee who left the company, but accidentally kept his access to NPM. And that meant that later on, his laptop was compromised by an attacker, and they were able to use his NPM account to get into, the NPM packages of Ledger. And so they published a malicious version of Ledger's SDK. And this SDK is used by thousands of companies. And so to answer your question, like what's the value? It's basically, all these companies using this SDK are just sort of blindly accepting whatever code is in that SDK and have no vetting process, no scanning process to tell them whether it's safe. And so when this attack happened, um, like thousands of apps were affected because they all just started pulling in the new version of this dependency. And so the cost of not doing scanning and looking for these attacks is that if any of your dependencies are compromised, you're just going to be affected by whatever new code has been added. And that could be anything. It could be lead to a breach, which leads to fines from the government, leads to you having to tell your customers that you lost all their data, which is very embarrassing for a company, obviously, and also can lead to losing customers and loss of trust. And really anything the attacker wants to do, they can do once they're running code on your system. So, let your imagination run wild. I mean, that's what could happen.
Very, very interesting. Yeah, especially for crypto, that involves a lot of money. I imagine that's very, very important.
Yeah.
Um, so, I mean, let's dive in maybe to. I think that was a software supply chain attack as well. I mean, there was SolarWinds, but most recently there's the XZ backdoor that we talked a little bit uh, about it at the beginning. Seems that was meticulously planned. Can you talk a little bit more about it and the lessons learned there?
Yeah. So if you haven't seen or read about XZ, I recommend you take a look at it because it's one of the most interesting, software supply chain attacks, or really any kind of attack that we've seen in a long time in the in the programming community. So what happened was there was there's this package called XZ, which is used in lots and lots of Linux service, and it happened to be included. I believe it was dynamically linked into the SSH process, and SSH is the thing that lets you control who gets into your server. It's on pretty much every server, and so turns out like this XZ package inadvertently, is just turns out to be pretty important because it can affect the way the SSH process works. And XZ was maintained by one person named, I think his name is Lassie Collins. And he had just been like thanklessly working on this package for 15 plus years. And, totally, it appeared to have signs of being burned out. Wasn't really working on it like super actively, but doing a pretty good job just keeping things going, kind of maintaining it. Not many really huge new features, just kind of doing the bare minimum to keep it going. And there was this intentional campaign by a state actor, and I think we now believe there's been public reports that this was probably the Russian government, but I think I don't know if it's still like if it's been kind of officially confirmed yet or not, but they created a series of personas, fake people that interacted with Lassie over the course of 2 years to convince him to give access to the project. And they did this like it was pretty impressive, like just the amount of effort they put into it, because it was like mailing list messages over years with different fake identities interacting and making it seem like he should really give access. And they did it in such it was kind of a mean way, in my opinion, because they would come in and say, hey, like it looks like you're not really maintaining this project super well. You're doing a bad job as a maintainer. And they sort of, kind of insulted him a little bit, made him feel bad about his efforts. And one of the personas was actually a nice person who was kind of coming in and making good code changes, making some contributions, trying to be helpful. And so they had both the mean and the good, the good cop and the bad cop. And the bad cop was saying, it seems like you really need help with the project. Why don't you share access with somebody else so you're not a bottleneck? And over here is a nice person helping out, making good changes. And so they basically were able to convince Lassie to give access to this nice, supposedly nice person. And then that nice person put a backdoor into the package. And that backdoor would have allowed the attackers to get into any server by bypassing, or basically what it would do is when you log in with SSH, you could provide a special RSA key to the server that contain a command, and the server would execute the command, even though the key is not authorized. So it wasn't really like it wasn't like a magic password that would let you into the server, but it would basically let you run any command on the server, which is just as good, basically. So imagine that, like, these attackers could have, basically gotten, run commands on any server that had this package on it, and that would have given them access to like everything, right? Could have been like one of the worst things, like one of the worst attacks ever. Like, I'm not exaggerating. Like, we were very close. But fortunately, what happened was somebody was running the beta builds of XD, and they noticed when they upgraded their XD package that their SSH got like half a second slower. And so they were like, why is my SSH a little bit slower? And they traced it back to this upgrade. And then they figured out that there was, some malicious changes made to that version. But it was like, if it wasn't for this total accident, right, like a very lucky coincidence that this person happened to notice this a couple months before this was going to go out in the stable build to everybody, right? We would have seen like a lot of damage from this attack, but we just got super lucky as a community, and it was caught, in the beta builds before it really affected that many people. So yeah, very close call, very crazy story, and very eye opening, I think, to a lot of people.
That's super interesting. Yeah, I remember studying Stuxnet and how sneaky that attack was in the Iranian nuclear reactors, and like these state actors, especially developed countries like US and Israel, they have a lot of resources.
Mm.
So let's talk about the use of LLMs. I was impressed uh, by you sharing a little bit more about how you were using in Socket. I'm not sure if you're already using production, but how you're using LLMs to help detect um, maybe attacks and things like that, and how the difference changed between GPT-3 and GPT-4. Have you experimented with Llama 3 now that they've released? Can you talk a little bit more about how you're using LLMs and maybe the future of that?
Yeah, it's really exciting to see the speed of development in this space. I think, we've been paying attention to this space for a really long time, like even before ChatGPT came out and really blew everybody's minds. We had already been experimenting with LLMs. One of the reasons is, like, Socket is very good at picking up lots of signals from packages. So for any open source package, we can tell you, is this package going to make network requests? Is your data going to get sent out? Or your environment variables or your files going to be accessed, all kinds of things like that. And our next step was we were going to build a kind of an ML system to really identify what combination of these signals means that a package may be compromised or may be suspicious, at least. And right around when we were about to build this system, we took a look at LLMs and specifically GPT-3, and we thought, like, GPT is actually pretty good at understanding code. And even though at the time a lot of people were really focused on the text generation, use cases, we had heard that it was pretty good at code, and so we wanted to try out showing it some code, some suspicious code, and asking it to determine whether the code was malicious or not. And so we prototyped a system that did that, and it was interesting, but not that impressive. We got like very high false positive rate, but it seemed like maybe a dead end, and so we kind of tabled it and didn't deploy it to production. then GPT-4 came out, and we were able to get early access to that through an investor, and we switched over the, it was like one line change in the code, GPT-4, and suddenly started performing much better. So it was still, pretty high false positives, but at least now I think it was something like 1 out of every 3 findings was really um, malicious, right, or sketchy in some serious way. And so that was great to see, because then it meant that, like, we could actually use it. Like, maybe we don't want to show these findings to our users because 1 out of 3, that's a pretty high false positive rate, but we could at least, as a team ourselves, look through this and identify lots of really interesting findings. And so we've been using that ever since. We deployed it straight into production back in, I think it was like May 2023. So we've been using it for over a year now, and it's been finding tons of threats. Like, we're finding over 100 malicious packages per week, thousands of suspicious packages that are doing things that are maybe not outright malicious, but that are really bad, like downloading code off of random S3 buckets, really weird steps happening in the install process, like lots of things that indicate these are not good open source packages that you would want to use in a serious production environment. So yeah, it's been great, and we're not using Llama 3 yet, but we've been experimenting with other models. I think we're not using Llama in production, but I think we were using Claude now as well. So we've tried. We're always trying new things and trying to see what works best. And it's evolving so fast that it's hard to even make a statement here about like what we're using, because it'll be out of date pretty fast. So yeah, it's
Yeah,
been awesome.
sorry. Yeah, Kevin Scott was talking about in a conversation with Reid Hoffman that GPT-5 or whatever the next version is very, very impressive. It looks like someone that can solve a PhD kind of problem versus high AP or high school problem. So we'll see what evolves there. How do you see not only these language models, but maybe looking 5-10 years down the road, how agents can help the security down the road? How do you see that changing?
Yeah, I mean, I think the biggest thing in security is there's a huge workload on security practitioners. They're just constantly processing alerts, and so much of our tooling in the security world is just so noisy, constantly firing off alerts, and so I think like it's a very hard job for humans to do, and it's one of these things that burns people out. People in the space, and not that different than open source actually. It burns people out pretty fast, and there's like a lot of mental health issues in the security world, because especially people who are on call to be monitoring these types of things. And so I think like an obvious use for this type of technology is to do the first line triage and massively like reduce the number of alerts people have to look at. So that's how we're already using it in Socket. Like, we use LLMs to prioritize what we look at, and I think we're going to see more and more of that. Like, if you have, even today, without it being PhD level, even though it's like high school level, you said, or a college and undergraduate level, whatever level you want to say, like, it's still useful, because if you can eliminate the obviously false positive issues, or you could at least sort in rough priority order, even if it's not perfect, you could still save people a ton of time and help them direct them to the highest priority issues first. So there's already opportunities today with the current level of sophistication to do prioritization, at least. And then like really long term, I mean, the thing that's powerful about these is that they're infinitely scalable. So, if yeah, I guess like imagine like an infinite army of PhDs, to use your model, right? And like, what could you do with that? I mean, you could automate a lot of drudgery, and like, and get like this sort of all the standard types of alerts that people see and deal with every day completely off the table with humans, and reserve like human time for the stuff that's like the most interesting, or the exceptional cases that are not handled well. So I think that's going to happen.
Interesting. So, I mean, security is a cat and rat race. And you have LLMs now being able to use to attack and maybe create code that's hard to decode. Are there new attacks that you start seeing that use LLMs as a tool to create them or amplify these attacks?
I mean, we see that in like phishing attacks already. People using LLMs to generate really customized, phishing messages. In terms of malware generation, I haven't seen anything that's clearly LLM based. We've seen a lot of like massively like spam packages that people are creating that typo squat on a lot of names and things like that.
Interesting.
But those seem pretty like manually done today. So I think the attackers are a little bit behind in using LLMs that I've seen, at least. Like I think it still seems pretty manual. But one thing I will say is they're aware that LLMs are scanning their code, because we've seen packages where they'll, next to the suspicious code, they'll have a comment that says like, this code is not suspicious. Like this code is bad. And then trying to basically convince the LLM that's right, that we've seen our socket. I actually, in its responses, it'll say things like, despite the comments that indicate the code is safe, the code is actually malicious. So it'll actually realize what they're doing and not be fooled by it.
Yeah, that's funny. I think I've seen an attack recently where someone uploads a video and the last frame of the video has text in it that's blacked out, with the background blacked out, that has the attack, saying whatever it is it wants, like the prompt injection there. So I think we're gonna see a lot of interesting attacks there. It's gonna be a very interesting area. So last question. This has been so interesting, and I've learned a ton from you. So what's the future of Socket in the short term, and what are you focusing right now? And what's the future of Socket, let's say 5 to 10 years down the road?
Yeah, so I think the short term is pretty clear. We want to expand to cover more programming languages and protect more and more of the programming community. So we're hiring right now across the board in engineering to basically help us ramp to more programming communities and improve our analysis so that we're always on the cutting edge. I think Socket right now is the only tool that protects against attacks the way we do, and we're the market leader, and I think we want to stay that way. So we do that by investing more in research, making sure that we're staying ahead, because like you said, it's a cat and mouse game in security, which is what makes it fun. Unlike in other types of engineering where the rules of gravity don't change. And so if you build a bridge today, the same bridge will work 100 years from now, because gravity isn't changing that fast or really at all. And in security, that does not work. So it's why it's very, very fun. And it's always challenging. Longer term, like in 5 to 10 years, I think if you just think about like the way we do software security, like we it's kind of in our field needs help. Software needs help. Like we're not a very like sophisticated discipline, to be honest. Like things are really broken, like in a lot of ways. Programming languages make it way too easy to create security flaws, and there's way too many foot guns, and there's it's way too hard to write code that just works correctly, and the amount of bugs, we do this iterative process, and it's a coping mechanism for the fact that like our tools make it really hard to do the right thing. And security, yes, it's a cat and mouse game, and it's a hard problem, but it feels like we're still dealing with the same problems in a lot of ways that we had 10 years ago, 20 years ago. Like things get better, but they get better so slowly. And so I just think the opportunity is really in trying to solve these problems at a more fundamental level. I think I'm very interested in, can you make a programming language that makes it impossible for a supply chain attack to happen? Like, can I define the capabilities and the permissions that I want to give to my open source dependencies so that even if they are compromised, there's nothing they can do, right? We have a sandbox. We have a permission system similar to how we might have on a mobile phone, where
Yeah. I was
You know,
just thinking about iOS, how iOS, is very secure and how they have, certain permissions and sandboxes and how apps are sandbox. Yeah, go ahead. Sorry.
no, you're totally right. On iPhone, like or in Android, when an app wants to access your webcam or your camera, it has to ask for permission. It doesn't just get to do it because they issued an update, right? So I think there's a lot there that we can bring to make software more secure at a fundamental level and reduce trust needed in the dependencies. And more broadly, I think just AppSec as a whole is still a pretty new field, and I think a lot of vendors in the space are just really focused on selling software to executives and not really thinking about the user experience for the developer. And I think the future is developer first security. So making the programming languages more secure, making things secure by design, secure by default, making frameworks and programming languages handle these issues for the developer, and I think like focusing really heavily on the developer experience, which is not something you see from a lot of security companies. Usually they get big, they build these broad tools that do everything but do it not very well. And I'm interested in building Socket into a company that can do more things than what we do today, but in a way where we do everything really well. And we built like, you know, best in class solutions in every new area that we expand into. So yeah, there's a lot of opportunity in security, and things are so bad now that it's like really hard to not see opportunity everywhere you look.
Awesome. Thank you so much for the conversation. It was a pleasure talking to you. I really, really, really appreciate your time. Where can people find you online and can find more about Socket?
So Socket, you can learn more at socket.dev. And we have a Twitter account, or I guess it's called X now, at Socket Security. And we have an amazing blog. If you're interested at all in security, or even just like news in programming ecosystems, like what's going on in JavaScript, Python, things like that, we have an amazing blog at socket.dev/blog. We do posts like every day or every other day. So it's a great resource, and we do these really in-depth posts. It's pretty special content, I think. And then me personally, you can find more at feross.org. And if anyone wants to email me, I'm happy. I love getting emails from people. I'm happy to be helpful or chat with anyone else who wants to, talk about stuff in more depth. So you can always send me an email. On my emails on my blog.
Awesome. Thank you so much and have an awesome week.